Hello students, again we are here to solve the question that will be based on the JEE advanced pattern. As you know, we have solved a few questions in the previous session, and now we are going to continue the session with some more questions with some more categories of the exam. So I can just see and scroll the question for you, and I can see that question number 8 to 9 is again the comprehension type. That means category has been changed and it has been converted to a passage type question. So the passage has been given, you have to carefully read the question first of all, and then we will be moving towards the question that are going to be associated with this particular passage. So in the passage, what we can read is that in the circuit shown in figure, points A, B and C, they are maintained at constant but may be different. They are maintained at constant but different potential. This A, B and C, right? Now when a resistance is connected between A and B, so no current is flowing through it. But when the same resistance is connected between B and C, like here, the current is flowing from C to B. One important, I cannot say one, but two main or important things can be found in the question itself. When they are saying that a resistance is connected between A and B and no current is flowing, we can say that the current doesn't flow in the circuit when the 2 points are at same potential. So that means from here we can declare that VA should be equals to VB, right? And when the resistance is connected between B and C, the current is flowing from C to B. So that means C will be at maximum potential, right? The second information. Now I can redraw this figure before you as like this. This is point D, this is A, this is C, and say this is B. Now VA equals to VB, and because we know that the C will be at maximum potential because current is flowing from C to B, right? So that means VC, potential of VC is greater than VA or VB, right? Now let me just suppose, because I do not know about the potential at VD, I am supposing the potential at VD is less than VA or VC or VB. I can write this VA or VB because VA equals to VB. So definitely if VD is less than VA, it is going to be less than VC also. So VD is less than VC also. Now if I want to draw the directions of current in this particular circuit, I can see that the current always flow from maximum potential to lower potential. Now because C is greater, so the arrow will be like here. At point D, because VD is less than VA and VB, so the current will be flowing from here, again from here. Because B is as maximum potential and also A is at maximum potential, as we have supposed this. This was an assumption from our side. Now because I can see that this cannot be the case because the current is coming from here, it is coming from here, and then it should go into this particular arm, but this is not happening. What is happening is current is coming from here and from here. This cannot be the case because where do the current will go then? The case should be like this, that current is flowing from here and then from here, then it will be coming like here, right? So that means our assumption was wrong. We have to consider that let VD is less than VC, but VD should be greater than VA or VB. So that means according to this assumption, if we are going to draw the circuit again, that will be, this is B, this is A, this is D and this is C. Now because D is at maximum potential, then C. sorry, D is maximum potential, then B and A. So that means current will be going like this. And because at C is at maximum potential, so the current will be coming like this. Now this should be the appropriate condition that we have drawn, right? Now we have drawn the circuit as the condition has been given. Now we have to begin with the question. What will be the question? In the question number 8, this question, that will be question number 8 and 9 that is coming before, these two will be based on the passage that has been given. When only 3 resistance shown in the figure are in the circuit, then current in resistor 2R is from C to D. This was the final circuit that we have drawn. And this was, let me just scroll the question again for you. This was the 2R resistance. This is R. This is 2R and this is 3R. This I am talking about the resistance. This is R. This is 2R. You can make like here 2R, and this is 3R. Right? Now what they are saying us in the question that what is the current in the, whether the current in resistance 2R is from C to D or not. So from C to D the current is flowing. We know that because we have considered that the C is at maximum potential, and in the question also it was given that the C was at maximum potential because the current was flowing from C to B, right? So that means we can see that from C to D current is flowing. That means this is the correct option. Current in resistance 2R is from C to D, right? Now the B option, because in the C and D we have been given whether both are correct and both are wrong. So to check whether both are correct, we have to check for B also. The current in 2R is 4 times the current in R. Now we have to find out the current in 2R and R in this arm and in this arm. Now because suppose this as current, total current I. So the I1 will be flowing through this, I2 will be coming to this. Now again apply the same formula. I1, let me just say this is I1 and this is I2. Now I1 will be, that will be I into R2 upon R1 plus R2. So that means I, total I into R2. R2 is 3R. 3R divided by R1 plus R2. 3R plus R, that is 4R. So that means this is 3 by 4I. Now if I take the case of I2, that will be I into R1 divided by R1 plus R2. So that means I into R1. Now the R1 is R divided by 4R. So that means 1 by 4 into I. This is the case of I1 and I2. In the option they are saying that current in 2R is 4 times the current in R. So if I take the case of current in 2R, the current in 2R is I, and the current in R, that means this resistance I1, this is 3 by 4I. So that means we have to take the ratio of I by I1, that means I divided by 3 by 4I. It is not coming out to be 4, but it is coming out to be 4 by 3. That means the ratio that has been given in the option is not correct. It is 4 by 3 times of I, but not the 4 times. This is not correct. Only the option that is correct in the figure is, in the options is this. Once again, let me just tell you one thing. This I, that means current in 2R, is coming out to be equals to 4 by 3 of I1. That means current in R. This is 4 by 3 and not the 4 times, right? So this was the question. Now we will be moving towards the next question from the same passage. Okay, if VA equals to VB equals to 10 volt and VC equals to 30 volt, then value of VD will be what? Okay, we have been given our figure. VA has been given as 10 volt, VB has been given as 10 volt, VC has been given as 30 volt. We have to tell the VD. I can see over here that if I will be talking about the current in this ICD will be equals to IAD plus IDB, right? So if I know the current, I will be putting this in place of current, I will be writing it like V equals to IR. So I equals to V by R. So that means I am going to write it like this. ICD equals to IDA plus I. Okay, let me just tell you, this was the condition that I have drawn earlier. This was not the correct arrows. So the correct arrows was in the figure that I have deleted right now. It was like this. So ICD equals to IDB plus IDA. Now I equals to V by R. So we can just apply the formula by Ohm's law. If I talk about ICD, so here my potential will be 30 minus VD. Let us suppose this as VD. 30 minus VD upon R. Here R was, again I have to go back to the figure that I have deleted. I have attempted a mistake. Let me just go back to this figure. I can see that this figure is having the resistance as 2R. So that means 30 minus VD by 2R equals to IDA. DA, that means VD minus VA. Now because the current is flowing from D to B, so we will be taking at VD minus 10 divided by the resistance, that is R, that is given in the circuit, plus IDB, again VD minus 10 divided by the 3R, right? So this R and R, that will be cancelled. We are having only with us 30 minus VD by 2 equals to 3VD minus 30 plus VD minus 10 into 3, right? So 3VD plus 4, that is 4VD minus 40, okay. This will be equals to 90 minus 3VD into 2. Simply you can solve this by using your mathematics skills, or when you will be finding out the value of VD equals to 170 by 11. Now my VD has came out to be 170 by 11 and we have to check in the options that whether it is available or not. Yeah, I can see that option number B is 170 by 11 volt is the correct option that we have just figured out from the question, right? So this was the question, and now we will be moving towards the next question, and when we will be see which is the next category that is going to be arrived now. Okay, so the last category is integer type question, and question number 10 to 11. This should not be 12. We are having only 11 questions before us. So 10 to 11 are the integer type question. Okay, so we will prepare board for you. Okay. So in this question, a galvanometer gives full scale deflection with 0.006 ampere. That means, as I already told you and as I frequently say you one thing, that focus on the question. When you are going to focus on the question, you are going to find the important things from the question which will be helpful for you. So full scale deflection with 0.006 ampere. So that means my Ig, the current in the galvanometer is 0.006 ampere, or you can write it as 6 by 1000 ampere, right? Now by connecting it to a 4990 ohm resistance, it can be converted into a voltmeter. The important thing in the question is that here it is being converted into a voltmeter of range 0 to 30 volt. Now if it is connected to this much of resistance, it becomes an ammeter of range 0.15 ampere. Now just go back to your flashback memory and just recall that what is that voltmeter and ammeter. When we are going to connect a high value resistance in series, that will become a voltmeter, and when we are going to connect a small resistance shunt with the galvanometer in parallel, then it will become an ammeter. So first of all, let me just talk about the voltmeter. As I told you, in the case of voltmeter, we connect a high value resistance in series. So a high value resistance that has been given as 4990 ohm resistance. This is connected in series with this galvanometer. It has been converted into, here Ig was coming. My Ig was 6 by 1000 ampere. Now when it is going from this, what has been given? It is giving the 30 volt range. So I can write it as V equals to I into R. My V is 30 volt, I is Ig into R. The total R now become as R that means G plus 4990. When I am going to put this value, let me just take another 30 equals to Ig. Ig is 6 by 1000. G plus 4990. When you are going to solve for this, you will see that your value for the G will came out to be 10. Right? So from here, my G has came out to be 10. Now another condition that when this resistor, this will be connected in, okay, this is connected. They are not telling us in which, you can say, in which direction it is connected or in which situation, position it is connected. But we know that for an ammeter, a small resistance shunt will be connected in parallel with the, say this is shunt resistance. This is connected in parallel with the galvanometer. Now what happens is the range will become then 0.15 ampere. So that means suppose if 1.5 ampere current was coming and Ig will go to it, so here the current that will be going will be 1.5 minus Ig. Now what we have to do is we have to find out the value of S, because we have been given this some value that is 2n by 249 and we have to find out the value of n. Now to find out the value of S, I know that, just suppose say that this is point AB and these are 2 points, say C and D, because these two resistors are connected in parallel. So that means VAB will be equals to VCD. Now what will be VAB? We know that potential will be same when two resistors will be connected in parallel. To find out the VAB, that will be I into R, Ig into R, R will be G, equals to VCD. VCD will be 1.5 minus Ig into R, that is shunt, right. Now Ig is 6 by 1000 into G, we know that value of G is 10, equals to 1.5 minus Ig. Ig is again 6 by 1000 divided into S. Now we can solve for this easily. This will be cancelled. We are left with 6 by 100, that will be equals to 1.5 minus 6, 1500 minus 6 divided by 1000 into S. So that means if you will be solving it, the value of S will came out to be 60 divided by 1494. This will be the value of S. Now what next? Because we have been given that if connected to a 2N divided by 249 ohm resistance, this value, that means S has been given as 2N by 249 ohm. That means 60 by 1494 is nothing but 2N by 249. We just have to equate them. So 60 divided by 1494 equals to 2N divided by 249. So from here the value of N will be into 2, or when you will be going to solve this, you will see that your value will be N equals to 5. Now we have to check whether N equals to 5 is present in all. Okay, this was the integer type, so no option will be available before us. Integer type question means the question that you have to encircle the bubble which is in your OMR sheet. You have to choose 1 to 9, 0 to 9. So that means in this question you are going to darken the bubble, that will be corresponding to 5. So answer for this question is N equals to 5, right. Now we are going to solve the next question, that will be the last question of the session. Okay. Okay, so the question says that in the circuit shown in figure, a voltmeter of internal resistance R when connected across B and C. These 2 points has been given, B and C. It reads the voltage as 100 by 3 volt. Now neglecting the internal resistance of the battery, the value of R is 5x kilo ohm. We have to find out the value of X. Again, integer type question. Okay, let me just draw the circuit again. This is 50 ohm, this is B, again this is 50 ohm, not ohm, this is kilo ohm. This is again 50 kilo ohm. Now, this is A, this is B and this is C. In the question what they are saying that when connected a voltmeter of internal resistance R, let me just mark over here, it is connected across B and C. This is a voltmeter, it is connected across B and C and its internal resistance is R, right. So when they are connected, they are giving the reading of, this is 100 volt and they are giving the reading of 100 by 3 volt. Now as you know that in the circuit when two resistors are connected, voltage is being divided into two equal ratios, not equal but because the resistors are equal, so they are going to be divided into equal ratio. So my total voltage, if I talk about the voltage across AB, that will be 100, that means total voltage minus voltage across B and C, minus 100 by 3. That means voltage across AB is 200 by 3 volt, or you can mark over here, right. Now what we have to do, we have to find out the value of this resistance R. we can easily do one thing. If I am doing that VAB upon VBC, and for what is the formula for V? V equals to IR by Ohm's law. So I, because in the you can say circuit, when two resistors are connected, I remains same. So if I will be putting the value of I, that will be same, I and I will be cancelled, I will be having the resistors only. So RAB upon RBC. Now VAB is 200 by 3 divided by VBC. VBC is 100 by 3. That will be equals to RAB. RAB is 50 kilo ohm. And in place of RBC, now I am putting the equivalent resistance, say R. Right? Now 200 by 3 into 100 by, divided by 100 by 3. So you will be left with only 2 equals to 50 by R. So that means your R will came out to be 25, right? Now because in the question we have been given that the value of R is 5x kilo ohm. So in place of 25, or I can equate this with as 5x kilo ohm. So in place of R, 5x equals to 25. So from here your value will came out to be 5. So the value of x is 5. Again you are going to encircle the bubble that will be corresponding to 5. This was the last question of the session. I hope you will be practicing further more questions. You are going to solve further more exercises. Keep practicing, keep revising. Just take care. Bye-bye.